Hello everyone. You're watching Computer Science Principles, Week 19, Day 2. Let's get to it. So we've got a bunch of stuff to talk about in regards to previous assignments. Then we're going to move on to loops and how they work. And of course, don't forget 050401, which is the lists make assignment, is due tomorrow, Friday the 15th at midnight. Let's get started. So to start with, I want to review assignment 050101, which was, of course, this PowerPoint slides with various problems you had to solve. In particular, slide number 13 caused people some problems, so I want to make sure we highlight what to do here. So insert item, a lot of people got confused on how this works. Insert item is a function. This function takes three parameters. We haven't really discussed parameters in this class yet, but that's what these things are. The list that you want to insert into, the index where you want the item to be inserted, and the item itself. When you insert 20 at location 1, everything else gets pushed over and 20 gets plugged in, like so. And if you were to do the same thing with 100, again, it would get stuck right here at index 1 and everything else gets pushed over. Some people were confused about erasing parts of this array or not pushing items over. This is how it works. Everything gets shifted over to the right and then the item is inserted. So please make sure you do that correctly. Next, let's take a look at slide number 15. In this slide, you were supposed to append, insert, and remove an item, so using all three ideas. And what got a lot of people is this line here. It looks scary, but keep in mind this is just a literal interpretation of some references within the list. That's all you need to worry about. You don't need to think about this as some crazy, scary code. Let's just go through it one step at a time. B listed 2, 0, 1, 2. That's PO. We can literally replace this, either on our mind or on our paper, with the word PO, or letter combination PO. B listed 0. That's 2. And I'm sure if I gave you this, now you'd have no problem. Obviously, all this is trying to do is add potato to the end of our list, right? Nothing crazy is going on here. The second line, remember, we always evaluate first before we do whatever the operation is. 2 minus 1 is 1, so we're inserting go at location 1. So go is going to go right here, like so. And then removing an item at 2 will remove the 5. This should be your final answer. If you got something else, you need to go back and reconsider. Next, we're going to take a look at code.org, where you were required to do 050301, which was to do all these bubbles. Let's take a look at bubble 8 together. A lot of people didn't change this sufficiently. Your month should only read as 05, the day should read as 21, and the year is 1994. You need to change these substring values to make that happen. I'm going to let you figure out how to do that. Bubble number 12. This is a little bit nitpicky, but when you want to remove the last item, if at all possible, since it's always the last item you're removing, do not hard code any value for the length of the list like this, and assume the list is always going to be 10 units long. That's not a good idea. Instead, you should always let the computer figure out what the last item is. You can do this by doing the length of the list. So since this is called song list, we say dot length and subtract 1 from it. That will find the length of the list, get the index of the last element, and remove that element no matter what the length of the list is. You should use this, not the 10 value. Alright, so that's all we have for reviewing things. If you have any further questions, please send me an email. Let's move on to loops. Hooray, loops! What is a loop? Well, suppose we have a little robot, and we're going to be guiding him around this grid. There are going to be some barriers which we have to avoid, and we'll have several commands we can issue. For instance, move forward. That'll make the robot move forward. Let's say we want to get him from here to the purple box. Well, we can do that by calling move forward 4 times. But that's really tedious and boring. So what if there was a faster way for us to code that? Well, there is. It's called a while loop. The while loop works as follows. You check a condition. If the condition is met, it's true. We do whatever's inside the loop, and we check the condition again. If it's still true, we do the loop one more time, and we check the condition again. We keep doing this until eventually the condition is reached as false, and we can exit the loop and continue. Sometimes you might write a loop where the condition can never reach the false state. It always is true. If that's the case, you've created an infinite loop, and that's usually really bad. So you want to make sure your check here eventually will result in a false return. So let's see an example. I create a variable called steps and set it equal to 0, and then I'm going to do this code so long as steps is less than 4. And inside here, I'm going to move forward and increment steps by 1. Well, let's go ahead and puzzle this out in our minds here. We start with steps being 0. That's in fact less than 4. So we'll move forward and we'll make steps be 1. Hopefully you now see kind of how this works. Obviously 1 is still less than 4. So we're once again going to move forward and add 1 to steps. We do this again. And of course one more time. Now that we've reached steps being 4, 4 is not less than 4. So we're done, and the loop ends. Here's a similar example, but we've not incremented steps in this one. It stays as 0. What's the problem? Well, if we run this, the robot will run forward as desired, but eventually it'll just keep going forever. Some say it's still going to this day. The problem is you never change this value. So this condition is always met, and this loop never stops. This is usually a really bad behavior that you want to avoid. Let's say we introduce some more ideas, so we could turn our robot to the right. So if we were to run this, well, steps is less than 4, and we would go forward and turn right 4 times, forward right, forward right, forward right, forward right, and that would end up being right where we started. Just another example for you. Now sometimes you might want to set up your loop like this, and it's a little tedious to write it out in this manner. Now while loops can be all kinds of other things. You do not have to follow this formula with having a variable. You always have to have some kind of Boolean in here, but you don't have to increment anything. You could have a check to see if a user inputted a specific value, for instance, where it just reads a field. Or seeing if a variable has reached a value of true, for instance, would be another way you could set up a while loop. But at any rate, if you are going to do this, where a variable is incremented every time, there's another option for you called a for loop. A for loop is structured as such. You first declare a variable. You can, of course, always leave this blank if you want, followed by a semicolon. Then you let the program know when we will stop. So we'll keep going as long as I is less than 4. And lastly, we tell it to increment I by a certain amount. So we can increment it by 1 like this, or we could divide it by 2 sometimes is a good idea, or instead subtract 1 from it. All kinds of things you can put here. But ultimately, how this works is this check is made every time we reach this line. Then we do the code inside, and once we reach the end, we will do whatever the last section of our for loop tells us to. So in this case, we'll move forward, we'll add 1 to I, we'll come back here, and we'll check if that 1 is less than 4, which it is, and we'll keep going. So very similar to the setup we have on the left here, just using slightly different syntax. Next class, we will pick up where we left off and continue with our exploration of loops. Thank you very much for coming, and I'll see you guys later.